Hello viewers, in today's session we are going to discuss a very important definite integral in which the integrand is of the form 1 over square root of q, where q is a quadratic polynomial, that is ax square plus bx plus c, right? So here we have the integrand of the form 1 over square root of q. So now here we see that we have the integral from 0 to 3, and here we have 1 over square root of 3x minus x square dx. So let us call this integral as I, and here the quadratic polynomial is given by 3x minus x square, right? Okay, so now to solve these type of integrals, what we usually do, we try to make a perfect square, that is we'll try to express this quadratic polynomial in terms of a perfect square, right? So for this what we will do, we'll first take because here the coefficient of x square is minus 1. So what we will do, first step is to take negative sign common from these two terms. So we have x square minus 3x, right? Okay, so now we have minus, and now we'll write this term as x square minus 3x over 2. Here we'll write a 2 in front of 3x, and then we'll add and subtract the square of 3 by 2, right? So here we'll write 3 by 2 square, then we'll subtract 3 by 2 square, right? So this is the usual method of changing a quadratic polynomial into a perfect square. So now we have x square as a square, then we have the term 2ab, right? So here we have 3 by 2 whole square as b square, right? And the middle term, that is 2 times 3x over 2, is minus 2ab, right? So a is x, and b is 3 by 2. So now these three terms give us the square of a minus b, right? And here we have minus 3 by 2 square, that is 9 by 4, right? So we have expressed this quadratic polynomial q as minus, here we have a minus b whole square. So this is x minus 3 by 2 square, and then we have here minus 9 by 4, right? Because if we again expand this square, we'll get the same term as 3x minus x square, right? Because see, here we have a minus b square, so we have a square, then we have b square, that is plus 9 over 4, then minus 2ab, that is 2 times here we can write x times 3 by 2, and here we have minus 9 by 4. So 9 by 4, 9 by 4 get cancelled, and here 2 and 2 also get cancelled. So we have minus x square, and this is simply 3x, and now we can write it as 3x minus x square, right? So we'll get the same quadratic polynomial. So now we can write our integral I as 0 to 3, then we have dx, and here we have square root of minus uh, x minus 3 by 2 square minus 9 by 4, which can also be written as 9 by 4 minus x minus 3 by 2 square, right? So multiplying these two terms by negative sign, we have now this quadratic polynomial. So we can write it as 9 by 4 minus x minus 3 by 2 square. So now to move further, what we will do, will make use of the method of substitution. So let us take a new variable z, that is equal to x minus 3 by 2. So dz over dx, differentiating z with respect to x, we have dz over dx is equal to 1, because the derivative of x with respect to x is 1 and derivative of 3 by 2 being a constant, it is 0, right? So we have dz is equal to dx. Now the limits of integration vary from 0 to 3. So when x is 0, then the value of z is 0 minus 3 by 2, that is minus 3 by 2. And when x is 3, then the value of z is 3 minus 3 by 2, that is 6 minus 3 over 2, that is 3 over 2, right? So now the integral I can be written as the limits are from minus 3 by 2 to 3 by 2. For dx we can write dz, and in the denominator we have square root of 9 by 4, which can be written as 3 by 2 square, and here we have z square. So now to integrate this function will make use of a standard result. So we know that the integral dx over a square minus x square is given by sine inverse x over a. So this is a standard result here. So we have a as 3 by 2 and the variable x is z here, right? So now the integral dz over square root of 3 by 2 square minus z square is given by sine inverse x over a. X is z and a is 3 by 2, right? And the limits are from minus 3 by 2 to 3 by 2. So I can be written as sine inverse 2z over 3, and limits are from minus 3 by 2 to 3 by 2. Now substituting the limits, and we'll take the difference. So here we have sine inverse 2 by 3 times 3 by 2. The upper limit is 3 by 2. Then minus, here we have sine inverse 2 by 3 times minus 3 by 2, right? So 2 and 2 get cancelled, 3 get cancelled. So we have sine inverse of 1, and here we have sine inverse of minus 1, because 3 and 3 get cancelled, 2 and 2 get cancelled, and we are left with only a minus 1. So we have sine inverse 1 minus sine inverse minus 1, and this is sine inverse 1 plus sine inverse 1, because we know that sine inverse minus theta is equal to minus sine inverse theta. So this negative can be taken out, and here minus and minus becomes plus. So we have now 2 times sine inverse 1. So now the value of this integral I is given by 2 times sine inverse 1 plus sine inverse 1 is 2 sine inverse 1, and sine inverse 1 is pi over 2, and 2 and 2 get cancelled, and we are left with only pi, right? Because sine pi by 2 is given by 1, so that sine inverse 1 is equal to pi by 2, right? So the value of this integral is given by pi.